Hi, welcome. This lesson is on exponent properties. First, we're going to talk about the components of a radical. Um, we've got this part, and that is the radical. The r is the index, and x to the p is what's called the radicand. And then we've got p is the power. P is the power or the exponent. And so a radical can be written as a term with a rational exponent. we can take this radical, the rth root of x to the p, and the index we can write that down here as well. Index of the radical becomes the denominator, while the power or exponent of and this should say radicand, becomes the numerator. So this p goes up to the numerator, and the index r here becomes the denominator of the exponent. Let's look at some examples here. So we've got 4r raised to the 4/3 power, and we want to, since it's in rational exponent form, we want to convert that to a radical. So we put 4r as our radicand, and the index is the 3. The index is the 3, and the 4 is the power. Now, this could also be written as the cube root of 4r, and then all of it is raised to the 4th power, and those are both equal to each other. Example 2, we've got it in radical form, so we're going to write it as in rational exponent form. So k is our radicand, becomes the term, and it's raised to the 5/6 power. Example 3, we've got n to the 1/4. So that is the 4th root of n, and then you could write the 1, but usually we don't. And then we've got the 7v, and that's all raised to the power 4/3. So that's how that works. We go back and forth between radical and rational exponents. So if the exponent on a term is of the form m to the n, where n is not equal to 0, then the number is said to have a rational exponent. 8 to the 1/3 is an example of a constant with a rational exponent. All the same exponent rules, this is the next page, all the same exponent rules apply with rational exponents as they do with the integer exponents. So when you multiply like bases, you add the exponents. So z to the 3rd times z to the 8th is z to the 3 plus 8, or z to the 11th power. 5 to the 6th times 5 to the negative 4 is equal to 5 to the 6th plus negative 4, or 5 to the 2nd power. 6 to the 2nd, 5 to the 2nd power. If you've got rational exponents, the same applies, but you have to make sure that when you're adding the exponents, they have the same denominator, common denominator. Let's look at this first example here. So we've got x to the 1/2 plus 1/4 power. Then we just have to, off to the side here, is to say 1/2 plus 1/4, and the common denominator is 4, so multiply by 2 in the numerator and the denominator. 2 times 1 is 2, and 2 times 2 is 4, and that's 2/4 plus 1/4, or x, which is, 3/4. So that's x to the 3/4 power. And down here, we've got 3 to the 2/5 times 3 to the 1/4, so that's 3 to the 2/5 plus 1/4, and 2/5 plus 1/4 multiply by 4 times 4, and here times 5 and times 5, because the common denominator would be 20. 4 times 2 is 8 20ths plus 5 20ths, and that would give us 13 20ths. And so this is 3 raised to the 13 20ths power. All right. If we look at the next example here, when you when you divide like bases, you subtract the exponents. So this with integer exponents, we can see this is m to the 10 minus 3, or m to the 7th power, or 4 to the power 8 minus negative 3. Subtracting a negative is the same as adding a positive, so that's 8 plus 3, or 4 to the 11th power. When you're using rational exponents, the same thing applies. You subtract the exponents. In this case, I'm going to have v to the 1/2 minus 3/2, and that's all over. This 2 stays down in the denominator because it's not like base. It's not part of the base of the exponent 3/2, so it stays down there. So this is v 1/2 minus 3/2 is negative 2/2, and that's the same as negative 1 over 2. And so this ends up being that negative exponent comes down, and you get 1 over 2v. All right, when you have a power of power, you multiply the powers. And so this is n to the 2 times 6, or n to the 12th power. Down here we get 8 to the 3 times 4, or 8 to the 12th power. So over here, I'm going to have n to the negative 3/2 times negative 1/2. And negative times negative is positive. And 3 times 1 is 3. So this is n to the power 3. And 2 times 2 is 4. So that's n to the power 3/4. All right. When you have a quotient raised to a power, that's the same as the quotient of those powers. Kind of distributes amongst that division. So this would be 3 to the 3 times 2, 6, over x to the 5 times 3, 15. So that applies when you're dealing with rational exponents as well. So here I have x to the minus 3/4 over x, and then here a negative times negative is positive 3/4. And then because this is negative, we want to get rid of the negative exponent. It becomes positive in the numerator. So we'd have 1 over x to the 3/4 plus 3/4. And that would be 6/4. And you could simplify that to 1 over x to the 3/2 power. Like any fraction, you can simplify the fractions. You should. All right. 0 exponents. Anything raised to the 0 power is 1, with the exception of 0x. This x cannot be equal. X cannot be equal to 0. But 4 is not 0, so 4 raised to the 0 power is 1. So here, all of this is raised to the 0 power, which means that all of that is equal to 1, just so long as neither m nor p are equal to 0. And then we've got x to the minus 1 is equal to 1 over x. So you have a negative exponent. It becomes positive in the denominator. So z to the minus 3 is 1 over z cubed. And 3 and n to the minus 4, it's negative down in the denominator. It becomes positive up in the numerator. So this is 3n to the 4th power. And then if we look at the next one, we've got 5x to the minus 8/3. That's equal to 5 over x to the 8/3. It becomes negative, positive down in the denominator. And then the next one, we have 4x squared raised to the minus 3rd power. That's 1 over 4x squared to the positive 3rd power. So it becomes positive down in the denominator, and that is equal to 1 over 4 cubed x to the 6th power. And if you wanted to multiply 4 times 4 times 4 to get that 4 cubed, that would be 1 over 64 x to the 6th. Down here, we got negative 3. So the negative exponent just implies the reciprocal. So this is the same as x to the minus 6 over 4. Just switch them, raised to the 3rd power. So I got rid of that negative on the exponent 3 by inverting those two. And then this is x to the minus 18 over 4 to the 3rd power. And then this x to the minus 18 comes down, so it's 1 over 4 to the 3rd power we talked about is 64. And then we've got x to the 18th down here is positive in the denominator. And that's how you would go through and solve that kind of a problem. All right, that's the end of this video. Have a great day.